Hey, Math 219 folks. I am working with some students' questions about the normal distribution. In particular, they have some questions that I would say are, fairly common. I have already put up a video about finding percentiles. This is actually what this kind of question is like. But given the fact that we've got, like a little bit of confusion as to what that means, let me kind of help you to understand the normal distribution a little bit better and then solve questions of this nature. So, engineers must consider the breadths of male heads when designing helmets. The company researchers have determined that the population of potential clientele have head breadths that are normally distributed with a mean of 6.1 inches and a standard deviation of 1.1 inches. Due to financial constraints, the helmets will be designed to fit all men except those with head breadths that are the smallest 0.6% or largest 0.6%. Okay, so this actually gives me everything that I need in order to do the work that I'm going to need to do. Okay, so allow me to kind of demonstrate what that's going to look like. One is I notice that the head breadths are normally distributed. So it's very important. And whenever I work with the normal distribution, anytime I'm going to do any kind of probability work with it, I'm going to actually generate a normal distribution graph to kind of show what it is that I'm working with. I would highly recommend this for you. It's one of those things that students that use it find it very easy and find it very easy to like organize their thoughts. Those that don't, these kind of things are much harder. So what does that mean? That means you draw a little picture of the graph. It's symmetric unimodal. In the middle, we're going to put the mean. And so the mean of this distribution is going to be mu equals 6.1 inches. And then over here, I'm going to put sigma equal to 1.1 inches. Okay? Now, what I'm going to do now is I'm going to actually look at this and I'm going to say, okay, well, what am I looking for? So due to financial constraints, the helmets will be designed to fit all men except those with head breadths that are in the smallest 0.6% and the largest 0.6%. So what I'm going to do is I'm actually going to like put on there, I'm going to kind of create a little bit of a cutoff. Okay, so that's the smallest 0.6% right over here. And this over here is going to be the largest 0.6%. It doesn't have to be exact. And I'm going to write that actually as a decimal because any one of our normal calculators are not going to be able to actually use percentages. They're going to use decimals. So that's 0.006. So what I'm going to look for is I'm going to look for a head size. Now, one of the things that I think is very tricky for students is to understand that these values down here, okay, the values that are down here on this axis, those are hat sizes or head sizes. So here we've got the mean of 6.1 inches, and over here we've got a certain head size, like a certain number of inches, don't know what it is yet, and over here we've got a certain number of inches, and we don't know what that is yet either. Okay, so what we're looking for is a certain number of inches. And the reason why I bring that up is that when we're doing the normal distribution and we're working with these kind of problems, there's really basically two problems. Either you're given a percentage or a probability, and you're asked for a certain value of the random variable, in this case hat size, that's what we're doing here, or you're given a hat size, and what you're asked to do is to find the value of the random variable. Okay, so what we're being asked to do, what we're asked being, so we're given a certain hat size or head size, and we're being asked for the probability. So on the one hand, these are our two problems. One, we're given a probability or percentage, and with that one, we want to go in and find a value of the random variable. Okay, in this case, a head size. And that's what we're looking for here. On the other hand, our two is we're given a value for the random variable, and what we're going to be looking for is a probability or percentage. Most people have a problem with number one, and that's actually what number one is asking me for here. So what I'm going to do is I'm actually going to be looking for a cutoff. I want to know, so what I have here is I have the probability, right? Okay, I know what that probability is. It's going to end up being 0.006. I know that probability over here. Okay, that's how big this region is right there. And that's what it means to be the 0.6th percentile, for example. So we've got that probability. And what I want to know is I want to figure out what my x is going to be, right? Because this is some x that's going to give me less than or equal to that 0.006, okay? And then this one over here, okay, that one's going to be a probability that x is going to be greater than or equal to, and I don't know what it is, but then on this side, again, we're going to have 0.006, okay? So what we have, right, is I've got two basic problems here. On the one hand, I've got the probability that x is going to give me less than whatever this cutoff is, okay? And then on the other hand, over here, I have the probability that x is going to be greater than or equal to some number, and that's also going to be 0.006. So let me show you what that looks like in StatCrunch. So when I go to StatCrunch, okay, I'm going to go into StatCrunch. I'm going to use my normal calculator, just like we did if we wanted to find a probability. My calculator's normal. And now what we can look at is we've got probability, and notice how x is less than or equal to, I don't know what this value is. Well, first, I want to put in my mean. My mean is 6.1. And then according to the problem, my standard deviation is going to be 1.1. Okay? And the probability that x is going to be less than or equal to some value is going to equal 0.006. Okay? And I can... Oh, cool. Well, look at that. Okay? So let me just... I'm going to copy that. So first, what I did was I put in my mean and my standard deviation, just like if I was finding a probability. But in this case, instead of putting in a value for the random variable, which I've been doing in previous ones, I'm going to actually put in the probability, or the area that's going to be covered. And what I've got here, okay, make that a little smaller. And there we go. What this tells me is, what this picture tells me is that the value that I'm looking for the random variable is 3.337. So that's actually the value for the random variable, 3.337. And that's the value over here. So x is equal to 3.337. On this side, on the other hand, if we look, we've actually got to change over that side. It's almost identical. It's just it's on the opposite side. And that's one of the reasons why I draw the picture, is so that it helps me to understand which side that I'm looking for, and it gives me which comparative that I'm going to use. So I'll go back here, and now I'm going to this one. And all I'm going to do is I'm going to change this out, and I'm going to make this 0.006. Again. So notice, probability is 0.006, but the greater than or equal to sign is the one that's used here, and that gives me the other side. And so that's 8.863. That's 8.863. Okay? And so what that's saying is over here, this is 8.863. So if I were to write out the sentence as to what this is saying, here's what it's saying. The smallest 0.6% of hat sizes are less than 3.337 inches. The biggest 0.6% of, and I think it's head sizes, hat sizes, same thing, are greater than or equal to, which actually just ends up being the same thing in the normal, 8.863 inches. And are less than, I should add here. And so that actually answers my question. So if I look here, right, what is the minimum head breadth that will fit the clientele? Well, that's the cutoff, 3.337 inches. What is the maximum head breadth that will fit the clientele? It's a minimum of 8.863. That's the maximum head breadth. How do we find that? We use the normal calculator again, but instead of using the random variable, right, this is the thing that we were looking for. We were looking for the random variable, and instead we put in that percentage. Okay? So, just as a review, I'm reading the problem. I'm going to set up my distribution, my probability distribution, to make it kind of look like this. I'll have my mean. My mean's in the center. I get my standard deviation. I just write that down as a matter of just putting together my information. And then I'm going to draw in this case, I want the smallest 0.6% and the biggest 0.6% on the edges. Okay? And then I'm going to use the normal calculator. The normal calculator, though, is different this time because instead of putting in the value for the random variable right here, we're going to put in the percentage written as a decimal, or what we really call the probability. Okay? And that gives us head sizes. The other way around, when we put in the random variable, we get out probabilities. When we put in probabilities, we're going to get values for the random variable. Okay, I hope that helps.